Hello guys, so we are back again and today we are going to do some more couple questions on GP. Okay, the first question on this is, okay, let me take the first question. Okay, there are a lot of questions today. Okay, so the first question which we are going to do is this question, okay, which is determine the number of terms in a GP if A1 is equals to 3, AN is equals to 96 and SN is equals to 189. Okay, so here if we see we want to find N. Okay, Sn is given, so one idea is of finding Sn is directly, okay, for that, but we should know the N term, last term. Okay, the last term, that is necessary because when we will substitute, okay, we need to find R. Okay, so let's find the last term. Okay, if we know the last term, then we can get the sum directly, okay, easily, compared to what we need to find. Okay, the main thing is getting R. Okay, we have given the last term, okay, which gives us a hint that we should use Tn. Okay, one more thing, here R is missing because in a GP if R and A is known, then the GPs means the complete information of the series we have, okay, or sequence. Okay, so let's find the Tn. Tn is equals to what? A R power n minus 1. Okay, now what Tn is? 96. What A is? 3. R power, how many terms are that we need to find out, right? Okay, now if we divide 32 is equals to R power n minus 1, keep it as A. Okay, now second thing, what is Sn formula? Okay, here you can see Sn is positive. Okay, so R will be the formula will be A into R power n minus 1 upon R minus 1. Okay, now further on, if I see A is what? 3, R I need to find out, minus 1 upon R minus 1. Okay, now Sn value is given, which is nothing but 189. Now 189 can be divided by 3, which gives me 63. Okay, so finally we have 63 is equals to R power n minus 1 upon R minus 1. Now please observe this step because it is the crucial step. Many children are not able to click this step. Okay, and this problem is very great problem. Okay, you will find it, means it will teach you a lot. Okay, how to use this R power n minus 1, that is the crucial. How you can use it? If I can write R as R n minus 1 into R power n, R power 1. Okay, if I write it, okay, if you sum it again, you again get R power n, right, minus 1 upon R minus 1. But R, okay, the crucial thing was R power n, you can write it as R power n into R power 1, n minus 1 into R power 1. Okay, now you know R power n minus 1 value 32, put it here, R minus 1 upon R minus 1. See, our question is so simplified. Now 63 into R minus 63 should be equal to 32 into R minus 1. If I move it here, I get 62. If I move it here, I get 31 R. Okay, so okay, R is equals to nothing but, okay, 2, sir. So R is equals to 2. Okay, so we got R is equals to 2 as our R value. Now, but we wanted to find N. So now if you see, if I have R, I can compare it. How many times is 2? 35. How many times? So let's put 32 is equals to, put it in A. Put it in A. Okay, so 32 is equals to what? 2 की power n minus 1, right? Now 2. Can I break it in two parts? Whenever you see GP, you try to, means to make your calculation easy, you should know at how many terms, at what power this can be broken into 2. Okay, we know at 3 power it is 8, at 4 power is 16, so at 5th power it should be 32. So 2 power 5 should be 2 power n minus 1. Now I can compare the power because my base is same. So 5 should be equal to n minus 1, right? So my n is what? N is nothing but 6. So this is our answer. Okay, and we will move on to the next question. Okay, we will move on to the next question. The next question is this. Okay, the next question is this. Question number 2, let me read the question. It says let S be the sum, okay, P the product and R the sum of reciprocal of n terms in a GP. We have to prove that P square R power n is equals to Sn. Okay, S is be the sum. Okay, S is the sum. Okay, now if nothing is mentioned, we will assume the GP as AR. Okay, this is the sequence. Okay, AR square. Okay, AR cube till what? Last term is what? Here it is 1, so last term will be T and will be T R power n minus 1. Okay, I have told you how A R power n minus 1 comes. Okay, one more thing, we want to find its sum. Isn't it very easy? We have done it many times. It is nothing but just the derivation formula of Sn, R minus 1. Okay, we got this thing. Our S job is done, so we found it this. Okay, our final answer should be like this. Moving further on, what is P? P is nothing but P is what? A into AR square. Hope you can understand what I'm. It is a product. Okay, it is the product of these terms till what? AR power n minus 1. Okay, now if you see, this A is 1 plus 1 plus 1 till what? N times. Similarly, this R is what? This R is 1 plus 2 plus 3 plus till what? N minus 1. Okay, you can see it is still n minus 1. Now you can write A as A power n, but R, if you know sum of n terms 1 2 3 4, okay, it is just application of method of induction chapter. There is a small chapter of principle of induction. Okay, like that chapter, a small chapter. Okay, I will cover that, but not now. Okay, we will do it after we are done with our algebra. Okay, it is not more useful when it appears. I will tell you. Okay, like the sum of these numbers till n minus 1. Okay, till whatever its value is n into n plus 1 by 2. Here it is, the last term is n minus 1. Let's put n minus 1 into n minus 1 plus 1 upon 2. Just remember this formula, and what we get, n into n minus 1 by 2. Okay, so R power what will be n minus 1 by 2, right? So we got our P thing. Okay, our one more job, P is the product. Okay, one more job is done. Okay, now let's focus on the next thing, which is R. Okay, R is nothing but R is what? Okay, let's okay, so let me write the series. Okay, for R I have to write the series again. Okay, for example, if you read them properly, you will understand what I mean. Sum of the reciprocals of the terms. Okay, if it is 1, it will be 1 by A plus 1 upon A by R plus 1 upon AR square till what term? Till 1 upon A power n minus 1, right? Okay, hope you have understand this thing. Now we want to find its sum. Okay, that is R. Okay, now here comes the crucial part. My A is this, right? Now here many children do mistake. Okay, it is very general that R is nothing but 1 by R. Okay, but what crucial is, they will do this mistake that they will write here R like this, R power n minus 1. Wrong, this is wrong. Okay, we have just know that R is positive. Okay, when 1 by R it will be less than 1, so don't write it here. Okay, that is wrong, never do this mistake. Okay, when a reciprocal is done, if the given means, if the sequence in means when it is not inverted, if the R is greater than 1, okay, then it will be here, and if it is inverted, the R will not be here, the R will be here. Okay, that is what becomes crucial. Okay, if you don't focus on this thing, your answer will be wrong. Here 1 by A upon 1 minus 1 by R power n. Similarly, the down means bottom, what will we write? Nothing but 1 upon R. Similar this thing. Okay, now the one more question many children means they are confused is like they mean that why you are writing n terms. Okay, it should be n minus 1. Brother, listen, 1 2 3 4 till it is n term, but here when tn term comes, it is 1 less than n. Okay, so here the term is power is n minus 1, although the number of terms are n only. Okay, so many children are confused in that thing also. Okay, so please don't do these mistakes. Okay, so if I means calculate it, what I get, 1 by A R power n minus 1, okay, upon R power n into R minus 1. Okay, here the r will come. Okay, now if we clarify it more clearly, I have 1 by a, okay, r power n minus 1 into r power n minus 1 upon r minus 1, right? Okay, we have this thing. Okay, now what we can do? Okay, what we can do now? What we can do? Let's think. Okay, so let's what we can do. So let's just put the values and just see. I'm saying that is there any modification which I can do? No. Okay, so let's put the values and see whether we can get. So p, what was our p? This thing, a n into r power n into n minus 1 by 2. Okay, the whole square, right? Then r power n, r is what? 1 by a r n minus 1 into r power n minus 1 upon r minus 1, right? Now this is whole power n. Okay, so what we can do here, what it will be? A power 2n. Here if I put the square, it will, this 2 will cancel out, which will give me r into n minus 1, right? This is very clear. Okay, further on, if here I put a power n will appear. Similarly here r power will be there. Okay, n square. Okay, here r power n, here r power n minus 1 the whole power n. Okay, so further on, okay, we have not done any calculation mistake, right? n minus 1. Okay, so here if I do r, okay, r power n minus, okay, let me think. Okay, if I bring it up, this r, it is what? n minus 1. Okay, n minus 1. Okay, we will not do anything right now, then but we will do it some. Okay, we will do, I want to make you understand what I'm doing. Okay, in the next step, this thing, okay, this 2a power 2n will be 1 2 means there are 2n, 1 n will be cancel out by this, there will be an, right? And this is rn into n minus 1. Okay, one more thing, if I move it up, okay, if I move it up, what it will be? 1 minus n. Okay, power n means plus n. Okay, now this is what? R power n minus 1 upon r minus 1 power n. Okay, so what we can do here, I think we have done one mistake. Okay, let's just, okay, it was a power n, right? Okay, here there is a mistake, this will be r power into n. Okay, when I move it up, it will become, this will not be in plus, it will be in multiplication, so it will be 1 minus n into n, and here we have n into n minus 1. Okay, these two, then r n minus 1 upon r minus 1 the power n. Here similarly, here will also be the power n. Okay, now here r power n, and here all this power will add up, which will give me n minus n square plus n square minus n. So here you can see all powers are cancelling out, which will give me 1, r power n minus 1 upon r minus 1 power n. Okay, so what we have? A power n. Okay, this will become 1, r power n minus 1 upon r minus 1 upon n. Okay, so this will nothing but a power n. Okay, how it can be equal to this? Okay, what I have s very, okay, this is my s. Yes, it is similar to like, okay, if I bring the power up, they will become same, r minus 1. Okay, now they are equal. Okay, so we have proved that it is equal to Sn power n. Okay, while means I want to solve the questions in as simple step as I can, so sometimes small mistakes occur. Okay, sorry for that, because it should be in multiplication. Okay, there is no r. Okay, there will be not addition. Okay, please avoid these mistakes. Okay, so we are done with the second question, which was proving this. Hope you have understand every point. Okay, I have told all the mistakes which children do. Okay, and please learn from means the things which I means if I do some mistake, please learn from them also. Okay, so let's move on to the next question. Let me bring the next question. Okay, this is the next question. Okay, now in this question, which says find the sum of n terms of the sequence of what? X plus 1 upon x the whole square, comma x square plus 1 upon x square the whole square, comma x cube plus 1 upon x cube the whole square. Okay, and so on. Okay, now even a small child, okay, who have passed class 10 will seriously understand that this basic thing, that if I open this, there will be 2 plus 1 upon x square. Don't you agree? Similarly here will happen as 4 plus 2 plus 1 upon x square, x power 4, x raised to 6 plus 2 upon 1 power x power 6. Okay, don't you think like that? Okay, okay. Now one more thing, this question is means very simple, nothing great. Okay, if here you can see that these terms are in GP while these terms are in GP, okay, while and these are just, okay, separate terms. So let me arrange x square, okay, x square plus, if I arrange it, see, it doesn't matter, the sum will be, okay, we want to find the sum, so we will put in plus x raised to 6 plus x raised to 8 and so on. Okay, I don't know at what term. Okay, and similarly here, okay, plus will be there, 1 upon x square plus 1 upon x raised to 4 plus 1 upon x raised to 6 until what, so on. Okay, now here 2 plus 2 plus 2 plus till what, n. Okay, okay. So now here what we can do, it will also be till n, so last power will be 2 power n, 2 x plus, means here will be x into 2n. Okay, here will be 1 upon x plus 2n, here will be 1 upon x 2n, sorry, x 2n. Okay, so now we want to find the sum. Here you can see the first term is x square, okay, the ratio, common ratio is 2, so n x ki power 2n minus 1 upon what, x square minus 1. Okay, so we are done with this, plus 1 upon x square. Okay, now here listen, the again the sequence is this and it is positive. When the sequence is reciprocal, here will be what, 1 upon x power 2n. Okay, you hope you have understand what I mean. Okay, just some form, this formula will be just reverse, 1 minus r power n will be used. Okay, that is the critical part. Okay, don't do mistake in this thing. Okay, then what will be 1 minus 1 upon x square. Okay, so we are, now we will simplify it. It is nothing but 2 power n. Okay, let me simplify this one. Okay, this is nothing but x square, you know, this is x power 2n minus 1 upon x power 2n. Similarly here x square minus 1 upon what, x square, this thing will cancel out. Finally I am left with x power 2n minus 1 upon x square minus 1 into x power 2n. Okay, plus here there will be 2n, here will be x square into x power 2n minus 1 upon x square minus 1. Okay, now what we can see, what you can observe, that these two terms, okay, x power 2n minus 1 and x square minus 1 are same. Shouldn't we take them common? X power 2n minus 1 upon x square minus 1, okay, are common. Okay, if I take them common, what I am left with, x square plus x power 2n, okay, plus 2n. So this is our answer. The thing which this question teaches us, that if sequence square is given, try to evaluate the question. Okay, that is the crucial part. Okay, if you have evaluate it, it will be x square plus, okay, 2 will come. Okay, separated that. Okay, try to identify different GP series in a single question, like it has 2 GP series. Okay, although there can be one more twist, that one can be in GP, one can be in AP. Okay, we will see that AGP, arithmetic geometric progression, okay, in further lectures. But before that, just observe the nature of the question, okay, very carefully, and be alert. Okay, be conscious. Okay, don't let these questions go wrong. Okay, they are very simple questions. Okay, okay, if you are aiming for J advanced, they should be in your on your tips. Okay, there is no difference between smart child and weak child. They just do large number of question. Okay, so they are, means they have confidence. Okay, that is the thing. There is nothing different between you and the smart child or the topper. Okay, so let's move on to the next question. Okay, the next question is this. Okay, prove that the sum of n terms of the series, okay, this series 11 plus 103 plus 1005 is plus so on is 10 by 9 into 10 power n minus 1 plus n square. Okay, now this is just the modification of question which we have just did. Okay, you can clearly see that if I observe, I can write it 10 plus 1, I can write it 100 plus 3, I can write it as 1000 plus 5. Don't you agree with me? Cannot we do that? Okay, okay, and so on. Okay, now if I, here you can clearly see that it is in GP, okay, and these three terms will form something else. Okay, so here I can see that 10, 100, 1000, okay, they are in GP, and 1 plus 3 plus 5 we will see. Let's separate them first. Okay, then 100 plus 10 plus 100 plus 1000 and so on. Okay, here 10 power n. Now one more question, that why 10 power n? Okay, why 10 power n minus 1? Listen, this is first, second, third. Okay, if I take t1 terms, it will be t1, t2, t3, like that. Okay, and while if I take AR, there will be an minus 1, because t1 at t2 there is AR, r power is 1 at t2, like that. But here it is 100, 10, okay, like that. At 1 power it is 10 power 1, okay, like that. So B means there should not be a single doubt in your mind, okay, why it is 10 power n. Okay, now this is one series. Now the other 1 plus 3 plus 5 plus and so on. Don't I know the odd last term? Yes, I surely know. 1, 3, 5, what they are? They are odd terms. Okay, so the last term will surely be 2n minus 1. Don't you think? Yes, the last term will be 2n minus 1. Now what it is a GP. Okay, first term is 10. Okay, r is greater than 1. Okay, 10 power n minus 1 upon what? 9. Clearly it is very clear that it will be 9. Okay, further on, if I move on, what do you think it is? If I 3 minus 1, 2. Okay, divide is, there is no option, you can directly see. GP is very easy to identify, the ratio. Okay, here dividing 5 by 3 doesn't make any sense. 3 by 1, okay, then you will check for AP. 3 minus 1, 5 minus 3, 2. So it is AP, D is constant. Okay, so AP sum is what? N by 2, n by 2. Now some people will think, why 2n minus 1? Brother, it is just the tn term, not the number of term. Okay, number of term are still n. Okay, now 2 into first term is 1 plus. Okay, no, okay, we can do it by one more way. Okay, okay, you can do it. Okay, 2n minus 1. Okay, n minus 1 into d is nothing but 2. But instead of doing by this, you can do by other method, that is n by 2. Okay, as we have used this method many times. First time I know, last time I know, 2n minus 1. Okay, very simple. Okay, this is very easy. While calculating it there will be manipulations. Why do that? Okay, because we want to prove something, so don't go in such time consuming thing. Try to make the thing short. Okay, because you don't have that much time in JEE. Okay, then this is 10 power n minus 1 by 9. Okay, our one part is complete simple. Now this one thing is left. You can clearly see 2 will cancel out, 1 is cancelling out, 2 will cancel out, n square. Hence proved. Okay, so we have proved this thing, hence proved. Okay, so what was this thing? As I have told, what I was tolding earlierly has came true in this question. What I was telling that there can be one AP and one can be GP. Yeah, you can see here clearly after analyzing the question that it will be 10 plus 1, 100 plus 3. Yeah, you will be not be able to click it at once, but after some time you will be able to click it. Just please keep, so when you solve the question, be conscious, and when similar question appears, okay, you will surely be able to it. That much intelligent every human is. Okay, so let's move on to the next question. Question number 5. Okay, question number 5. Sorry, question number 5. Okay, this is question number 5. Okay, now this question, find the sum of the following given series. Okay, 0.6 plus 0.66 plus 0.666 plus till what? Till n terms. Okay, till n terms. Okay, now how we can do this question? Okay, till n terms, how we can do this question? Okay, what? Now this question is just a means a second type of which question we have done that question earlierly, which was 5. Okay, 5 plus 5, 5 plus 5, 5. Okay, plus 5, 5, like that. 5, okay, this will be 3, this will be 4. Remember this question, just a modified. Okay, although you should know this also, you will not be able to click it by once, normal. Okay, nothing great. Okay, just after doing this, similar question appears with 3 term. Okay, fine, you will surely be able to do this. So now what is the different in this question, we will see how we have to do it. As I have told, this question is just you have to learn the approach, nothing scientific and logically. Okay, if I will take 6 common, what I will left 0.0.11. Okay, 0.111. Okay, and so on. Now second step was, in that was multiplying it by 9. We will multiply by it 9, 0.99. Okay, plus 0.999 and so on. Okay, okay, now what will be the next step? That is the most important. Okay, means here 6 by 9. If anyone is thinking I will write it 10 minus 1, please get some help, because this is 0.9. How can you even think of doing that? Okay, otherwise this question would be a similar question to previous 5 like that question. Okay, so please use your brain. 0.9, then it surely be 1 minus 0.1. Similarly 1 minus 0.01. Similarly 1 minus 0.001. Similarly 1 minus 0.0001. Okay, so hope you can understand what I mean. Okay, what hope you can now the second means the crucial part comes here. Okay, which is if I write it 6 by 9. Okay, this is 1 plus 1. Now you have to just arrange the term, 1 plus 1 plus 1 plus till what, n times. Okay, you know this basic thing. Okay, further on what we can do, we will separate this one, take minus common. 0 point, many children get confused while writing it. 0.1, 0.01, write it 1 by 10 plus 1 by 100. Okay, plus 1 upon 10 power 3. Okay, 1 upon 10 power 4, like that, and so on till 1 upon 10 power n. Okay, now this is just a GP of common ratio 1 by 10. Okay, first term is 1 by 10. Okay, now the second thing, which that here a r is less than 1. Okay, so use this one, 1 upon, okay, 1 by 10 power n. Okay, power n. Okay, don't do that mistake. Okay, then 1 minus 1 by 10. Okay, then you can do what step next? This is nothing but 6 by 9. Okay, whole. Okay, whole, this is n. Okay, how I will modify this? Okay, this is nothing but 10 will cancel out, you know this, and 10 minus 1 will be 9. So 10 power n minus 1 upon 10 power n, this is 9. Okay, so this is the modified, okay, of this thing, this whole thing. Then what is my final answer? 6 by 9 n minus what? This thing will cancel out. Okay, this can be cancelled out. Okay, fine, we are not cancelling it out. Okay, if I do it, my calculation will become simple. This is nothing but 2 by 3. Okay, so final answer will be 2 by 3 n minus, okay, what, 2 by 3 9s are 27, 27 into 10 power n into 10 power n minus 1 upon, okay, this is my whole, 3 9s are 27. Okay, so this is my answer. Okay, so this was whole thing. Okay, this is my answer. Okay, the thing which it teaches this question is nothing but that you should take 1 minus 0.1, 1 minus 0.01, 1 minus 0.001. Okay, that is the crucial part which you should learn in this question. Okay, the advanced questions are made from these small concept questions. Okay, so please, these questions should be in your mind. Okay, solve it that much time that you should be conscious. Okay, these questions should be in your mind, these steps. Okay, now moving on to the next question. This is the next question. What does it tells and how we will do it? That is the means, that is, this question is means quite a good level question. Okay, you can expect this type of questions in JEE Main. Okay, now find the sum of 1 plus 1 plus 2 plus 1 plus 2 plus 2 square plus 1 plus 2 plus 2 square plus 2 power 3, similarly until n terms. Okay, now one thing that as any child can tell, that here at first it was 1, then 1 plus 2, then in the third term what it was, 1 plus 2, this whole thing, then 2 square, similarly, and the last here this thing plus 2 power 3. Then you can solely say that the last term will have 1 plus 2 square plus 2 cube. Don't you think like that? Till what? Okay, till which term? 2 power n. Okay, now if I know the Tn means the last term sum, then I can use that. Okay, I can use that to create, means to get all the terms, like this term I can put the value and get. Okay, I want to find any relation, I want to analyze this series. So here I am not able to click how I should do. Using this 1 plus 3 plus that thing is means complete stupidity. Don't do that. Okay, now we want to find the last term and then analyze. In this type of question which has 1 plus 2 and this term is repeated, this is the simple process. Okay, find the Tn, analyze it and identify the series. Okay, what its sum will be? It is a GP. Okay, with common ratio 2, 1 into 2 power n minus 1, and here you can see 2 minus 1 is nothing but 2 power n minus 1. This is the sum of n term, means of last term. Okay, so Sn is this. Okay, now if I see, if I put what is T1, T1 is nothing but 2 power 1 means 1, right? T2 is what? T2 is what? 2 power 2 minus 1. T3 is what? T3 is what? 2 power 3 minus 1. Now if you observe one thing very clearly, that every term has minus 1. Shouldn't I bring all the minus 1 separately and place this series like this? So what this series is actually is nothing but 1 plus 2 power 2 plus 2 power 3 plus 2 power 4, and till what? Till we can take it till whatever I want, n terms. Okay, 2 power n doesn't matter. Okay, 2 power n. Now here I know every time I means I will take the minus sign, every term will have a minus sign. Then 1 plus 1 plus 1 plus 1 plus till what? N time. Okay, now we want to find out the sum of this thing. Okay, the common ratio is 2. Okay, very simple, 2 into 2 power n. Okay, okay, this will be 2, here will be 2. Okay, here will be 2 plus 2 square plus 2 cube. Okay, we did this mistake. Okay, now listen what mistake we did and why it is necessary to understand that mistake. Okay, this is 2 square. Okay, this series will begin from what? 2 power 2 means 2 power 2 minus 1. Okay, 2 power 1, 2 power 1. Okay, so this will be 2. Listen, even though it is 1, okay, the mistake which children do is writing this series. Okay, which I did also. Okay, then I analyzed that this series is 2 into 1. Okay, if it was this, then it is the sum of the n terms. Okay, so I came to know that this is something is wrong. Okay, the thing which was wrong is in a T1 I calculated this, that it is 1. Okay, I put it as 1. That is the mistake. You should take 2. So it is 2 square 2 cube, like that, and here the minus 1 you taken here out. Okay, otherwise it would have been n minus 1. If you place here n minus 1, then fine, nothing wrong, you can use this sum. But I will take 2 plus 2 square plus 2 cube because it is more easy. It will make my calculation simple. 2 power n minus 1 upon 2 minus 1. Okay, so this is my sum and this is my n. Okay, and what we are getting? 2 into 2 power n minus 1 minus n. Okay, so we got this thing, and if I multiply, there is nothing great, 2n plus 1 minus 2 minus n. Okay, so this is our answer. Okay, the crucial thing was in this question you have to find the sum of Tn term, analyze its nature, and identify T1, T2, T3, how I can make a GP out of that or AP out of that, HP out of that, and then solve the question. Okay, so that was the main part. Now let's move on to the next question. The next question is this question. Okay, it tells if the sum of n terms, okay, sum of n terms is 3 power n minus 1, then find the sum of the series whose terms are reciprocal of the given GP. Okay, in terms of, okay, it is a GP. Now I know one thing, that T1 is equals to S1 is equals to what? 2. Okay, so we have the first term. Okay, for Tn, what we can do is, let's just do one thing. Okay, we can write Tn as Sn minus 1, right? This formula is applicable in every AP, GP, HP. Okay, so we can do Tn, find Tn like this. Okay, They have a phobia that this formula is for AP. Okay, please avoid that phobia. Okay, what this is 3 power n minus 1. What it will be? 3 power n minus 1. Minus means plus 1. So what I have? 3 power n minus 3 power n minus 1. Right? This is, if I take 3 power n common. Okay, 3 power n common, 3 power n minus 1 if I take, then it will be, okay, I want to make it simple. Okay, if I remove this thing, okay, okay, it will be 3 power n upon 3 power n minus 1. Okay, so minus 1. Okay, this will be nothing but 3 power, if I bring it up, everything will be negative. 3 minus 1, 3 power n minus 1, because many people don't understand this step. Okay, 3 n minus, so I did this simple way, okay, to make you understand. Just take the 3 power n minus 1 in the bottom, okay, and then move it up. You will come to know that it is 3. Okay, many children don't know this thing, so I am doing that. Okay, if you are smart, that so you can understand it's a bottom. So what I am getting, tn is nothing but this. Now the second part, find the sum of the series whose, the sum is already given. Okay, find the sum of the series whose term are reciprocal. Means if t1 is what, 2 into 3 power 1 minus 1 means 0, means 2. Okay, and t2 is what, 2 into 3 power 2 minus 1 means 6. Okay, so it should be 1 by 2 plus 1 by 6, like that series. Okay, we want to find the sum of this series. Okay, but if I write it in this manner, means if I write it as t1 plus t2 plus t3, okay, like this, okay, and so on, the first term will be 1 upon 2 power, okay, 2, right, and the second term will be 2 power 3, the second term will be 1. Okay, similarly the third will be 2 into 3 power 2 and 2 power 3 power 3, and third term will be, and the last term will be, okay, we can write it as 3 power n. Okay, okay, 3 power n. So after doing this, what we came to know, that we can take 2 common from all of this, 1 by 2 common. When I take 1 by 2 common, I have 1 by 3 plus 1 by 3 square, okay, until so on. Okay, okay, so what we can do, okay, here 1 is 2, 3 power 1, 3 power 2, 3 power 3. If it is one term, this is 2. Okay, one term is power is 1. This will be 3n minus 1. Okay, 3n minus 1. Okay, now what we can do, okay, we want to find the sum. So this is a GP, you can clearly see that. So 1 by 2 into 1 into this is less than 1. Okay, so what we have to do, 1 minus 1 by 3 power n. Okay, n minus 1 is the power, n terms are there. Okay, I am telling it again because many people forgot that. Okay, then 1 by 2 into what, 3 power n minus 1 upon 3 power n. Here it is 2 by 3. Okay, so what we have finally, 3 by 2 into 3 power n minus 1 upon 3n. Okay, here it is 2 to 1. I think it will be 4. Okay, this 2 will multiply, it will become 4. Okay, this is the answer. Okay, I can move this up. We have 3. I'll move it down. What, no matter what the question, 3 power 1 minus n, it will become 3 power n into 4, 3 power n minus 1. Okay, this is the answer. Okay, so we are done with this problem. Let's move on to the next question. Okay, and we will continue. Okay, we will move on to the next question. Okay, so the next question is this one. Okay, which says prove that the number 49, 4489, 4448889 obtained by inserting 48 in the middle of the preceding number, okay, are square of an integer. Okay, integers. Okay, now what they mean, that if I take 49, in the next they have inserted in between, means if this is 49, okay, they have inserted in between a 48, which is 48 9, like that. Okay, similarly in between these they have inserted 48 into 8 9. Okay, like this. So hope you have understand how the terms are formed until so on. Now these terms, okay, this question is precisely about to teach you how you means write a term. Okay, how you break a term. Okay, because many children, what they do a mistake is they if I tell them to break 49, okay, in what sense I am telling it? In this sense, they break it at 40 plus 9. Wrong, don't do that, otherwise your question will be wrong. You should break it like this: 4 plus, okay, 4 into 10. Okay, in this question you should break it like this. Okay, it will tell you to, it will guide you to form a series. Okay, otherwise you will be stuck. Okay, if you break it like that, okay, you will create a trap for yourself. Okay, further on, so how you I have told how to break 14. Similarly, can we break 4 4 8 9? It will be nothing but 9 plus 8 into 10 plus 4 into 100 plus 4 into 1000. Okay, so you have broke it. Now similarly, can you break this? 4 4 4 8 8 9. Yes, we can break it. 9 plus 8 into 10 plus 8 into 100 plus 4 into 1000 plus 4 into 10 to the power 4 plus 4 into 10 to the power 5. Now the main important thing comes here. Okay, now I want to analyze the last, means the last term. Okay, last term. Okay, let's say it has some 44 4 dot some 4 terms. Okay, now similarly 8 8 8 some 8 terms. Okay, till, and at the end you can observe fg last term as 9. Okay, now if you observe in every term, okay, this is depending upon your observation, 44 is half the term. Okay, is half the term, and the next half term is 89 889. Okay, like that. So if I assume that these whole term are 2n, what 2n? Okay, 2n, then this should be n. Don't you agree? And this should be what? N minus 1, and the last term will be this. Okay, so how can I write this term, this last term? Okay, so how will I write? If I write it separately, okay, and this separately. Okay, pin setting 48 of the preceding number. Okay, we want to prove that this last term is this square. Okay, number in Zubtin binds. If I analyze the last number, then it is true for all. Okay, so we will analyze the last one, this one. Okay, now we are analyzing the last term. If I tell this is sum of 40, some 4 4 4, some 8 8, then plus 9. Okay, so this is nothing but 9. Okay, 9. Then if we analyze 8, okay, analyze 8 is what? 8 here, it is n, this is n minus 1, and then it is decreasing. Okay, hope you can understand. Then it will be 10, 8 into 100 plus 8 into 10 power 3, and so on till what? 8 into 10 the power n minus 1. Listen what I am doing. This is n into 10 power 0. This is nothing but 10 power 0. One term 9. So we are getting 9. Now this is 8 into 10, and then at what? Till what term? N minus 1. Okay, you are understanding what I am telling? Till n minus 1. 8 10 the power n minus 1. Don't write it from here. That is the mistake I was telling in the starting. Don't write it from here, write it from here. Okay, further on, now we are done with 8. Then we will do for 4 plus. Now we will move from here. 4 into 10 the power n. Don't you think, if this is n, here it is from n to what? To n. Total term will be, this will be 2n. The last is nothing but the n power 3. Okay, so this will be 2n. So the second one will be what? 4 into 10 the power n plus 1. After that 4 into n power n plus 2. Similarly what? 4 into n power 2n. Okay, so you have, hope you have understand this thing. That is the main tough part of this question. Okay, this question is of above J means you can expect, means this is more than half of a J advanced question. Okay, so this thing you have understand. Okay, 4 into 10 the power 4 into n plus 1, 4 into 10 the power n plus 2. Okay, like that. So how we write the term, that is the crucial. Start from this side. Okay, this side, this is n minus 1, and till here this will be n minus 1. Okay, they think that this is the n minus 1. Wrong, this is the n minus 1. You moving like this. Okay, this is the n minus 1. This will be what? 2n. Okay, this is 0, 10 power 0. Okay, how it is 10 power 0? Okay, because we want 9. Okay, that's why it was 9. You can understand from here. Okay, from this small example. Okay, that gives you some sort of path. Okay, further on, now if this is 9, I take 8 common. What I have? 10 plus 10 square plus 10 cube. Okay, till what? 10 power n minus 1. and here if I take 4 common, I have 10 power n plus 10 power n plus 1, okay, till so on 10 power 2n. Okay, now let me take the next page and let's solve this. We have 9 plus what, 8, okay, 8 into what, first term is 10, okay, into 10, our common ratio is 10. 10 power what, 10 power, listen, these are n terms, okay, we have already told you these are n terms, okay, these are n terms, okay, these are n terms. Don't do this mistake, because many children just take it as, okay, they do mistake, they get confused, take it as 2n. Please don't, avoid this mistake. It is nothing but n terms, okay, I am telling it. So 10 power n minus 1 upon 10 minus 1, right? We are done with this, okay. Sorry, I was doing fourth one, okay. 4 into 10 minus 1, okay. Now for the eighth one, okay, the first term, if you see the first term, okay, if you see the first term, what it is, n, again here it is n, okay, and here, okay, the first term here it was 10 power n, sorry, 4 into 10 to the power n minus 6, right? Now here the first term is 10, okay, in 8 the first term, and how many terms I have, n minus 1, okay, I have told here n minus 1 term, in the power what I place, n minus 1 term, okay, n minus 1 term minus 1 upon 10 minus 1, right? So what I am getting, 9 plus 4, okay, 4 by 9 into 10 the power n into 10 the power n minus 1, okay. Similarly here 8 by 9, okay, 8 by 9, okay, here will be 10, the first term, 10, the first term we forgot to place here 10, okay, you can expect here 8 into 10, okay, so 80, okay. Similarly here 4 power 10 doesn't make any great thing, okay, into 10 power n minus 1, okay. Now we want to prove it as a sum of, means this as a sum of, means a square, okay. How we can prove it as a square, okay. So if we observe clearly, here 9 is there, okay, 9 is there, okay, this is into 10, let is right as, okay. If I do one thing, okay, what we can do, the base is common, 4 into 10 the power n, okay, into 4 into n plus 2n, it will become 2n, okay. So what we can do, this is n plus 1, okay. If I move it inside, I have 4 into n plus 1 minus 10 power n, right, upon 4 by 9, okay. 9 is common in both, this is 8, okay. If I move it here, I have 10 power n minus 10, okay, outside is 8, okay. They both have 9 base common, okay. Similarly here it will be what, 8 plus, okay, 4, 12, okay, 12, no, they need to be, okay, I have to do some manipulation or what, 10 minus 8 and, okay, minus 2, let me think. So I am confused how I can form it a perfect square, okay. So let's do it, okay. So let's just do it again. 9 plus 4 into 10 to the power n into 10 to the power n minus 1 upon 9. This was this thing, and here it was 8 into 10 into 10 to the power n minus 1 upon 9. So how I can form it a perfect square, okay. So let's make the base same first. The problem should be 81 plus, okay. And here if I move the 10 inside, what I have, 10 power 2n, okay, minus 10 power n, okay, plus if I move the 8 inside, what I have, 10 power n minus 10, okay. Hope you have understand this basic thing. After that, let's just simplify, okay. This is 4 into 10 to the power 2n, and this is minus 4 into 10 to the power n. This is nothing but 8 into the 10 to the power n, and this is 80. What we have, 9, can we see a perfect square? 1 plus 4 into 10 to the power 2n, okay, minus 4n, this is plus 4 into 10 to the power n upon 9, okay. It is a perfect square. If you observe clearly, it is 1 square, 2, this is the 2 into n, okay. This is the square of 2 into 10 to the power n, okay, this is square of this, okay. This is 2 into 2, the term are 1 and 1 comma 2 into 10 to the power n, okay. If I square this, okay, I get this, okay. So it is nothing but 1 plus 2 into 10 to the power n by 3 the whole square, Okay, so we have proved that it is a square of integer. Okay, now, okay, so we have proved what we wanted. Let me check the question again. Okay, haven't we proved what we wanted? Where is my question? Let me get the question. Okay, the question is the number of 4 4. Okay, the preceding number are a square of, okay, it is solely a square of an integer. Okay, if I place the n value, I will come to know that it is a square of an integer value. Okay, so this was the question. Okay, now let's move on to the next question. Okay, this question means a tough question, not a simple question. This next question. Okay, the question is as follow. Okay, this is question number 9. Using the sum of GP, prove that a power n plus b power n, where a comma b comma n belongs to natural number, is divisible by a plus b for odd natural number n. Hence, prove that 1 power 99 plus 2 power 99 plus still 100 power 99 is divisible by 10100. Okay. Now, it is means if it is divided by a power n plus b power n. Okay. So let's divide it. Okay, so we will divide it a plus b power n upon a plus b, because I cannot say anything. Okay, if we get any something from here, then we will equate it and see whether we can get us. Okay, a plus b. Okay, now what we can do next? Uh, I think we can make it sum of terms. Okay, like how a power n into, okay, here we want to find a form of something. Okay, let's see, a power n, then what we are getting, 1 plus b by a power n. Okay, upon, if I take a common, what I have, 1 plus b by a. Don't you think it is nothing but a power n minus 1? 1 plus, okay, now what they are telling, by using the sum of GP, prove that n blown is divisible by a for odd natural numbers. Okay, now how can I prove that it is n is odd natural number? If I take here minus sign and place here minus b by a, okay, we will come to know that it is odd, because why, it will be minus b by a again. Okay, so we are just using minus into, okay, minus b by a. Okay, so we are writing it like this. Okay, now you can see that our common ratio is nothing but minus b by a, and our first term, okay, first term is what? Think just smartly. If you think, you will come to know what is our first term. Okay, what is our first term? A power n, we have taken common, and a common, this is our first term. Okay, a power n minus 1. Okay, so our first term a is a power n minus 1. Okay, our common ratio is minus b by a, and n is odd. Okay, so can we form the series? Yes. A first term is n minus 1, second term is what? If I take a common, okay, a n minus 1 will be everywhere. Okay, then this will be what? Minus b by a, n for 1 power. Okay, for 2 power it will be b by a, b square, a square. For 3 power, b cube minus a cube. Similarly, for 4 power it will be 4 plus a power 4. Okay, then at what, then if we reach here, minus 1 power, we want to make them understand n is odd, minus b by a power. Okay, we have just taken 1 here, then okay, n minus 1. Okay, so we are done with this. Okay, so okay, here will be n minus 1. Okay, I'm not doing any mistake, right? Okay, so if I move a n by 1 inside, what we have, a by n, again a by n, a minus b by a, and this will be minus 1. Okay, this will minus 1, a minus 2, a minus a plus 2 minus a minus 3. Do I am doing some mistake or what? Do we are doing some mistake or what? Because I cannot see a perfect series. It is not forming a sum, means not a, and I am not able to get the series. Okay, not a decent series it is forming. Okay, what series, what a mistake I am doing? Let me check. A power n minus 1, 1 minus b by n. Okay, right, fine. Wait, Okay, the first term should be a power n minus 1, then a into r. The series in GP, the series, okay, I am writing it like this, ar square, like this. So the first term is a. If I move it out here, it should be 1. So that is what I am missing. Okay. Okay. So we are done with this. Here will be 1. So what I am, a minus 1 into a power n minus 2 into b plus n minus 3 b square until so on. Here in the last, what it will happen, minus 1 power n minus 1 and this a power n will cancel out this a power n, we will be left with b power n minus 1. Okay, so we are done with this thing. Now what we can do further, okay, if you can see, okay, if it is broken into some parts, okay, some terms, okay, what that it means, it is divisible by a plus b for odd natural number. Okay, so we have proved that the sum of GP, okay, that an plus bn GP, okay, its sum is divisible by a plus b. Okay, now if you see, observe clearly, don't you see it is nothing but odd a power n plus b power n. Okay, it is nothing but a series. So we have proved that it is divisible. Now we want to find the number, is it divisible by this? Okay, now let's see the sum is forming what. How we can check that is one more trick thing that you should learn and teachers don't teach in class. Okay, so just be careful and see and understand. Okay, I have 1 power 99. If I combine it with 100, okay, the last term from the back is 99. Similar 2 with 99 power 100 and 99. Okay, similarly 3 with what, 98 by 99, and the last term will be what, here it is one less, okay, 50. Okay, if it is 2, it is 9, 1 plus 100. Okay, so it will 50 power 99 plus 51 power, okay, 51 power 99. Okay, so the last term will be this. So here they are forming 101, they are forming 101, they are forming 101. So it is whole divisible by, if it is a power n plus b power n is divisible by a plus b, then 1 plus 99 plus 100 by 99 odd power should be divisible by this sum, which is, it is divisible by, it is divisible by what, 1 plus 100, what it is 101. So it is divisible by 101. Now similarly, if 1 power 99 I take, okay, and now what I take, if I take 99 power 99, okay, similarly 2 power 99 plus 98 power 99. Okay, and similarly if I go on, okay, if I go on, what I have 48 power 48, okay, 49 power plus 51, 99 power. Okay, okay, now if you remember, we have left 100, so it will be 100 power 99. Okay, now what they are forming, what these are forming, it is forming 100. Let me take the next page. They are all forming 100. Okay, like here a plus b, it was divisible, so it should be divisible by 100. So it is divisible by 100. Now we just seen that it is divisible by 101, and we have just seen that it is divisible by 100. In the starting, we want to prove a plus n plus b power n is divisible by a plus b. What was the purpose? Because if we prove that a plus b it is divisible, then here if they form 100, then it is divisible by 100. If it is from 101, they are divisible by 101. Similarly, we did that and we got to know that they are divisible by 101 and 100. Okay, further on, if we have studied this thing in AP, that if there are two series, okay, it's d something, it's d something, okay, and we get a third series, okay, and they're telling that there are some common terms between them, okay, find the d of that common term series. Okay, what you should take, LCM, lowest common multiple of that both series. Okay, similarly here they have one sum, okay, its divisor is something, one GP divisor is something. This will also be in GP because this a plus n plus b power n having n odd is GP. This is GP, it is divisible by 104. This is GP, it is divisible by 100. So their LCM is very easy to find. 100 into 101, which is nothing but 10101. Okay, 1010. So we have proved, hence proved. Okay, hence proved. Okay, so this is the basic application. This question was tough. Okay, I will accept that. Okay, now let's move on to the next question. This is the next question. Okay, this is the next question. Okay, find the sum of the series, which is nothing but under root plus 1 plus 1 plus under root 2 minus 1 till infinity. Okay, now till infinity term came. What does it tells you? Sum of infinity terms directly. Now here a is what? Under root 2 plus 1. Now r is what? 1 upon under root 2 plus 1. Okay, now someone will come and tell me that under root minus 1 r is under root minus 2 by 1. Now just see this, how. Please don't judge a problem just by small thing. Just try to do some manipulations here. If you manipulate it or manipulate this one, if I manipulate it by under root 2, okay, and in bottom there should not be irrational terms. Okay, so I will manipulate this under root 2 minus 1. This will 2 minus 1. Okay, divide and multiply by what? Under root 2 minus 1. Under root 2 minus 1. Okay, that thing which you will do, you will come to it is under root 2 minus 1. Okay, so our r is under root 2 minus 1, hence proof our r is same, so it is a GP. Confirm. Now its sum is very simple. What? A is what? Under root 2 minus 1 plus 1 minus r. It is under root 2 minus 1. Simple. Under root 2 plus 1 upon this thing will add up, gives me 2 minus under root 2. If you observe, the next step will be under root 2, which will give me under root 2 minus 1. Okay, now what we can do, if I multiply this under root 2 plus 1, I get under root 2 plus 1 the whole square upon under root 2. This will become 1. Okay, similarly this will become 3 plus 2 under root 2 upon under root 2. So we got the sum, okay, which is nothing but 3 plus 2 under root 2 upon 2. Okay, so this was the sum of this series. This question involved just to make you confused that r is different and you think of something else different. Okay, some different type of series which is not invented in this world. Okay, some children do that, they think of AJP and they create their own some nonsense series. Okay, so please avoid that. Okay, now let's move on to the B. This was A question. Now let's take the B. If we see, okay, this question is very easy. This a 2 term power 2 term are in GP, while 3 term are power in GP. So I will separate them 1 by 2 plus 1 by 2 power 3 plus 1 by 2 power 5 and so on. Okay, is in GP. Similarly, my second term 1 by 3 square plus 1 by 3 power 4, 1 by 3 power 6 and so on is my GP. Now both will be till infinity. Don't take a confusion that it will be 3 power 2n, this will be 1 upon 2n. Okay, they are infinity. They are telling that it goes to infinity, that both will go to infinity. Please don't make this mistake of taking 1 upon 2n minus 1. This, because it is a 2n minus 1 you will take, and here it is a 3 power 2n. Okay, please don't do that. Okay, if you see any problem going to infinity, just when you break it, just make it to infinity. Okay, this is the basic illusion which children have. Please don't do it, and in between there will be plus. Okay, now I want to find its sum. Okay, so 1 by 2 is my first term. Okay, 1 minus 1 by 2. Okay, 1 by 2. Okay, 1 by 2 square. Okay, here r is 4. Okay, so 1 by 4. Okay, if I calculate it, what I have, 1 by 2 into 3 by 4, which gives me 2 by 3. And here, okay, here what we have, this will be 3 square. Okay, 3 square, which will be 9, 1 by 9. So 1 by 3 square into 1 minus 3 square. Okay, so what we have, 1 upon 3 square will cancel out both and it will be 8. Okay, 3 square is cancelling out, it is 1 by 2, that's why it is not cancelled, 2 is moving up. So we have 2 by 3 plus 1 by 8, which you can simplify this thing. Okay, we have added these two. Okay, or I should simplify it, 16 plus 3 upon 24, this is nothing but 19 by 24. Okay, I have did that. Okay, so our both problem is done. This was basic. Confusion part was what? It goes from infinity. When you broke, both will go to infinity. That is the basic confusion which children have. If it is going to infinity, please consider it as going to infinity. Don't try to find the last term. Okay, this means this is in sum of infinity terms. If you do mistake in this, means you're very weak. Okay, please don't do these mistakes. Okay, now the next question which we are going to take is this. Okay, if each term of an infinite GP is twice the sum of the terms following it, then find the common ratio of the GP. Okay, here the trick part is the language, English language. Okay, if you don't know your English language is weak, please such type of things come in sequence and series. Okay, and permutation, combination, probability. Okay, these chapters test your language skill. Okay, how much you understand the chapter language. I'm not talking about your English power. Okay, that doesn't matter. Chapter language, after you solve some question, you will understand the meaning of, means the way the chapter speaks, okay, in English. Okay, what it telling, that the term, if I take T2, it should be twice T3 T4 T4 till last term. Okay, if I take T1, it should be T2 T3 T4 twice T2 T3 T4 till all the terms, sum of all the terms. Okay, if I take T3, it should be twice T4 T5 T6, means after that term twice of sum of all the terms next. Okay, okay, and this gives you another hint that it will be an infinite GP. Okay, don't you think how it can be possible if a second term is greater than, means all sum of all the twice all the terms. Okay, this also gives a idea. Okay, if I consider the GP as AR square, which is the basic thing which we do, then A should be twice AR plus AR square. Okay, till what? AR power n minus 1. Okay, and this is nothing but a GP. Okay, okay, following. Okay, infinite, they have told infinite word, so it will be till infinity. Okay, our problem is solved. It is AR upon 1 minus, this is what, R. Okay, and this is A of first term. A will cancel out, which will give me 1 by R is nothing but 2R, which will give me 1 by 3 is R. So you have understand that is infinite GP. You equated the first term should be twice AR square. Okay, I didn't read, I was just miss. Okay, after I came to know that it is written infinity, I did the infinity, and then we got the answer, which is R is equals to 1 by 3. That is what we needed to find out. Okay, so let's move on to the next question. This question was just checking your chapter understanding language, okay, skill. Okay, now the next question which we are going to see is this question, 12th question, which says if x is equals to a plus a by r plus a by r square till infinity, y is equals to b minus b by r plus b by r square till infinity, and z is equal to c plus c by r square plus c by r by 4 till infinity, then prove that x by y by z is equals to ab by c. Okay, we want to prove this. Now x is nothing but infinite GP. Okay, you can see it. If I divide this by this, I have 1 by r as my ratio, a upon 1 minus 1 by r. What you get? AR upon r minus 1. Okay, my x part is complete. Y, here r is minus 1 by r. Okay, please don't get confused. 1 plus, okay, 1 by r. Okay, okay, minus minus will become plus. Okay, and this will be upon r plus 1 into r. Okay, further on, what we have next, we have c, which is not z, sorry, z, which is c. Okay, here common ratio 1 upon r square, 1 minus 1 by r square. Okay, this is nothing but c r square upon r square minus 1. Okay, now what we want to prove? We want to prove x, y by z. Let's put the value. X is what? A r upon r minus 1. This is nothing, means there is nothing means understandable in this question. You have to just understand that you have to just follow the sum and just divide it to get the answer. Okay, this is nothing but sum. To get the x value, you have to do the sum, and it is infinite GP. It is very clear. C r square upon r square minus 1. Don't you think it is r square, a minus b, a plus b? This whole will cancel out with this, r square will cancel out with this. What we are left with? ab by c. So we have proved that it is equal to ab by c. Okay, hence proved. Hence proved. Nothing great in this question. Okay, now let's move on to the next question. Okay, the next question is this question. Okay, teachers, when they are teaching in class, they mostly do this question. Okay, while preparing you for the IIT, they teach you this question. Okay, or the triangle. Okay, number of triangles inside a triangle, like that questions. Okay, this is one question. We will do that question also, but you have to wait till the first future lectures. We are doing a lot of problems, so it is taking time. Okay, question number 13. A ball is dropped from a height of 120 meter. After striking a floor, the ball rebounds 4 by 5th of the height from which it was dropped. Then find the total distance that it travels before coming to rest. Okay, now if we see, if I drop a ball, okay, if I drop a ball, this is 120. Now if I tell you find the 4 by 5th of the height of this, it is nothing but 4 by 5 into 120. Okay, please, you should know this. Okay, okay, now if I, the distance covered by the ball. Okay, now if I dropped it, okay, it will first travel 120 meter. Okay, then it will bounce back. Okay, to what height? Plus what height? 4 by 5th into 120. Okay, now it will travel, if I travel this day 4 by 5th, okay, it will again move down with same distance, so twice of this. Okay, so twice of this time. Okay, so twice of this, and then it will again rebound and 4 by 5th out of this, and then again come. So 4 by 5th into 4 by 5th into 120. Okay, like this. And similarly here it will do again 4 by 5th into 4 by 5th into 4 by 5th into 120 until infinity, if you understand properly, like that. Because because if you don't consider any resistance, okay, striking floor, the ball will keep rebounding till infinity. Okay, now it is nothing but 120 plus 2, okay, into this. If you observe 4 by 5, okay, if I take 120 common, okay, 120 common, okay, let me do here 120 plus, okay, 120 into 2 into 4 by 5 plus 4 by 5 the whole square, okay, till infinity. Now you can see here 420 plus 240, okay, here it is what, 4 by 5 upon 1 minus 4 by 5, sum of infinite terms of a GP, which gives me 120 plus 240. Okay, this is nothing but 4 by 5 into 5. Okay, so this 5 will cancel out, which will give me 120 plus 240 into 4. Okay, into 4. So if I do this, what we have, 120 plus 960. Okay, what we have, 0 8 10 1080. So our total, now listen what I'm telling, the explaining the question again. Drop from 120 height. If you drop a thing from this height, some height, let me take the, if I drop it from here, it will cover this distance. And okay, now it is telling if this distance, okay, I dropped it from here and it will cover this 4 by height of this. Okay, I say this is the 4 by height, then it will bounce back, travel the distance twice. Okay, then again it will travel the distance twice, 4 by 5th of that, again. Okay, there is no air resistance, so it will keep on till infinite time. Okay, one more thing, it will travel 120 once only. Okay, then it will travel 4 by 5th and then come in again. Okay, move up and come again, means twice of what distance of 4 by 5 it travels. Okay, every time, that is the basic. So 120 plus 2 into 4 by 5 into 120, then 2 into 4 by 5 into 4 by 5 into 120, like that till infinite times. Okay, so this was the question. Okay, like that happens in triangle, inside triangle. Okay, so please, so let's move on to the next question. Hope you have understand this question. This question is taught in classes. Okay, so it is easy, I have told you. Hope you have understand what I meant. Ball is dropped from height, it will cover that building's height or whatever height it is for, then it will travel 4 by height, but it has to go back again to rebound again, so it will travel 4 by height into again that height. Okay, and 10 it will form a infinite sieve. 120 will be separate. Why? You have understand, because it will fall first, reach the ground, for that it has to travel 120 distance. Okay, so hope you have understand. And the 4 by 5, how you do a 4 by 5 distance of anything, 4 by 5 into that height. Okay, that is the basic, all you need to know. Okay, and let's move on to the next question. Okay, the last question. Okay, this is the last question, which tells if an infinite GP has second term x and its sum is 4, then prove that x belongs to minus 8 to 1. Okay, 1 included, x excluded 0. Okay, so how we can do it? So let's take the common ratio r. Why we are taking? Because they have given second term. Okay, if they have given first term and second term, then we would have find common ratio. Okay, for we need the first term. Okay, to prove whatever we need the first term, for that how we can get, if we know the common ratio. The first term will be what? Okay, first term will be what? Now if you remember a series AR, okay, AR square, if I divide AR square, if I divide this term by R, I get the second term, and if I divide this by R, I get the first term. So the first term will be nothing but x by R. Okay, now they are telling an infinite GP. In infinite GP, A is very crucial, that's why I taken R to find the A. So first term we have got. Okay, now AX upon R into 1 minus R 1 minus R. Okay, first term A upon 1 minus R, okay, is nothing but 4. Okay, so x by R minus R square is equal to 4. So x is equals to 4 into R minus R square. Okay, now this we want to prove x belongs to minus 8 to 8. Okay, if you observe clearly, R minus R square, it is a quadratic. If I take minus outside, square minus R. Okay, a quadratic, this quadratic. Okay, A is negative. Okay, like this, if it was positive like this. Okay, now here is I have made a positive, okay, a greater than, so like this quadratic. Now it is minimum value, what it is, I can make the perfect square and check what value it is. Minus is out, minus is outside, 1 r, divide this by 2, 1 by 2 the whole square, and take a perfect. Okay, listen what I'm doing. At what second number, what number it is, divide it by 2, I divided it by 2. Okay, so r minus 1 by 2, make it a perfect square and take negative, okay, negative of that 1 by 2 outside. Okay, it will form your perfect square. Okay, this is the basic process you have to follow. Then move inside minus 1 by 4, okay, minus r minus 1 by 2. Okay, so here maximum value will be 1 by 4 of this. Okay, if I now this I have converted positive for my calculation, I have converted again, it is negative, so there will be maximum value. Okay, minimum can be anything. Okay, we will come to know how. Okay, so our maximum value we got, which is 1 by 4. After if we place the r value, keep on placing the r value, we will come to know it is decreasing. Okay, so our max means 1 by 4 is our max value r. Okay, r belongs to, okay, but if we know in infinite GP mod r is less than, so r belongs from 1 to minus 1. Okay, okay, so we can come to know it will be, because it can be anything. So let's, if we know minus 1, let's place it and check where it gets. Okay, it is nothing but if I place minus 1, okay, it will be 1. Okay, 1 minus minus 1, okay, minus 2, so it is belong from minus 2 to 1 by 4. Okay, this 4 has nothing to do. Okay, it is just a multiple. Okay, x depends on 4. Okay, r doesn't depends on 4. Okay, so what we can do, if I place it equal to 0, if at some root r is equals to 1 and r is equals to 0, this 4 will go on. Okay, that is, we have done so many question quadratic. I don't think that these small things are necessary to be explained. Okay, sorry if you don't understand, but I have done so many questions on quadratic, so I'm not teaching it. Okay, so I know that r belongs to this 2 to 1 by 4, 1 by 4 included. Why? Because we found it by this. Okay, it is included because it is at maximum point. Other ways to find is minus d by 4a, you can do that. Okay, the quadratic equation, you will get the same value, which is the maximum value in minus a parabola. Okay, a less than 0 parabola. Now, so we found this thing. Further on, okay, now I want to get x belongs to. Okay, now here, okay, now r is equals to 0 is not possible. If r is equals to 0 possible, then this will, second term will not exist, first term will not exist only. Okay, so that thing is wrong. So r is equals to 0 not possible, so we will include that r is equals to 0. Okay, if I place r is equals to 2, okay, let me take the next step. Okay, put r is equals to 2, put r is equals to minus 2. What you get? X you get 4 into minus 2 minus into 4. Okay, which is nothing but 4 into, let me check, 4 into minus 2 into 4. Okay, 4 into 6 minus 6. Okay, you are getting 4 into minus 6. Okay, minus 24, if I am right. Okay, x, here it is x 4 times r minus r square. So minus 2 minus 4 minus 2 minus 4 minus 6. Okay, minus 24. Okay, okay, if I place x is equals to 1 by 4, what I have, 1 by 4 minus 1 upon 16. 4 take common, they will cancel out, which will give me 1 minus 1 by 4, 3 by 4. Okay, 3 by 4. Okay, so we are getting this thing, x belongs to minus 4 to 1. Let me check what mistake I am doing. Okay, what we can do, what mistake we are doing, we got the number. Okay, why we are putting this value, these are the maximum. Okay, sorry, what mistake we are doing was this, that listen, x is equals to 4 into r minus r square, right? So we know its maximum and minimum value, which is minus 2 and 1 by 4. Okay, included, right? And 0 excluded. So 4 times this will give us our answer. Okay, but if you want to get this value, you have to place r is equals to minus 1 here. If you get this, if you want to get this value, okay, you get it by making the quadratic. Okay, that was the application of quadratic chapter. Okay, when you came to know the maximum minimum value of this, okay, then you multiply it by 4 and get the x. That is simple. This is minus 8 and 1, and this will be same, 8 not included and 1 included except 0. What we were doing, that we were putting the maximum and minimum value and checking what is r. Okay, that is the wrong concept. Please don't do these mistakes. Okay, okay. I sometimes get involved in questions so much that I start doing wrong things. Okay, so after that I realize, yes, this is wrong. I think again, and then I do, because r should be outside this value. Okay, x should be outside this value, and it is 4 times that value. Okay, so now it is right now 2 minus r minus. Okay, so what was the purpose? If you find the maximum minimum value of any r minus r square, okay, r minus r square, which is what, minus 2 and 1 by 4, you got the maximum and minimum value and it is 0. Okay, then you will multiply that number with that maximum and minimum value and you will get the maximum minimum value of x. Okay, that is the main thing which you have to do. Don't put the maximum and minimum value in r and get, because they are the maximum and minimum value already. Why you need to resubstitute them? Okay, okay, so that is the basic thing, and this hence proved. Okay, hence proved. Hope you have understand the last part. Okay, that was the thing, how we found the maximum minimum thing. We don't know the minimum because I have run the graph. It is very clear, it can be anything. So we know the r is between minus 1 to 1, so we know it will be before minus 1, so we put r is equals to minus 1 to get the minus 1 value, minimum value, and then we got r minus r square minimum value, then it will be 4 times x minimum and maximum value. So we are done with this problem, and it brings us to the end of this lecture, and we will see you into the next lecture. Okay, till then take care, and we will do some more problems on GP, understand it more clearly, because after that HP is just reverse of AP, while we can make combinations in AP and GP. Okay, so we have to be very clear in AP and GP. So that is all, and it brings us to the end of this lecture. Okay, so okay, see you in the next lecture.